Hello, and welcome to the 5th clinic in linear algebra. In today's clinic, we are going to look at how we can use row reduction to solve systems of linear equations. Okay. So I want to solve this system. Well, what we do is we recognize that we can write the system of linear equations as a matrix equation. Right? Specifically, we can write it in the form of AX equals B, right? A is what's known as the coefficient matrix. X is our vector of unknowns, right? And then B is our constant vector. All right. Well, in this example, our coefficient matrix, right? We look at the first equation. First row is the coefficient, so 1, 2, -1. Then we hit 1, 3, 1, right? And then 3, 8, 4. Our vector of unknowns, just x, y, z. And then our constant vector, 3, 5, 17. Okay. Now what we can do is represent this entire system to solve it as an augmented matrix. Specifically, A augmented with B, okay? So again, for this example, what we're going to get is the augmented matrix 1, 2, -1, 1, 3, 1, 3, 8, 4, and then augment with 3, 5, 17. All right, so the idea now is we can either put this augmented matrix in REF form, right? So that'd be Gaussian elimination. Or we can put it in our REF form, right? So we can row reduce it. That is called Gauss-Jordan reduction. I always just use Gauss-Jordan reduction. It's easier. Right? It will immediately give you a solution. Gaussian elimination would require some back substitution. So we're going to put this matrix into RREF, okay? Right? So what we do is we look for the first pivot, right? That's this one up here. That's the 1, 1 entry. So let's zero out everything below it. All right, so this is what we get. Our next pivot is this 2, 2 entry. So let's zero out everything below that. Our final pivot will be that 3, 3 entry, right? We just have to make that a 1. If we were using Gaussian elimination, right, this is where we would stop. And we would say, oh, look, Z is 4/3. Then we use backward substitution to find y, and then to find x. But I'm going to go to the next step, which is to put this in RREF. So we take this one, the 3-3 entry, that's our leading one, and we eliminate everything above it. Okay, this is what we get. Now we take the leading one in the second row, right? That's that 2-2 entry. Let's zero out everything above it. Right, and then the whole purpose of that is now this right here is our solution vector. Right, so two ways we can write that. We can actually write it as a vector, so we can say that the x vector, 17/3, -2/3, and 4/3. Yeah. Or we can write it as an ordered triple. Doesn't matter. Go ahead and solve this system. Right, so here I'm just going to jump to setting up the coefficient matrix. Yeah. I'm sorry, not the coefficient, but the augmented matrix, right? So we're going to get this. And now we're going to do Gauss-Jordan reduction. Right, so that 1-1 entry is our first pivot. Okay. Now, if you're really clever, you can stop here and recognize the contradiction. You can't see it, right? The next step would be the 2-2 is our next pivot, so zero everything out below it. Now here, you can stop, right? Because what this is saying, what this last row is saying is that 0 is equal to 3, which is nonsense, right? Right, so our solution is the empty set. There is no solution. So let's look at this one. All right, so first set up the augmented matrix. We now want to row reduce it, right? So that 1, 1 is the first pivot. So we zero out everything below it. And if you're really clever, you already see what's going to happen. Right? That 2, 2 entry is our next pivot, so zero everything out below it. Right, now notice that third row becomes redundant, right? It says 0 is equal to 0. That's a true statement. Okay? So it's redundant, but I'm going to leave it in there anyway. We only have one leading one then. That 2, 2 entry is our only leading one. So zero everything out above it. I'm sorry, not row 3. Right now, we look at this and we go, okay. The first column is going to represent X. The second column represents Y. The third column represents Z. Right, and that fourth column is just our constant. So what this is saying is that the first row says X plus 10Z is equal to 0. Second column says Y minus 7Z is equal to 1. We look at this and we go, well, that third column, right, the Z column, does not have a leading 1. This means that Z is an independent variable. It can be whatever you want it to be. X and Y are then dependent on that value. So here we're going to have an infinite number of solutions, and I'm going to write it as a set of ordered triples. Right, so our solution set of ordered triples. Let Z be anything. I'm going to say Z is R. Well, then X is of the form negative 10R, right? Because, again, this first equation is this. The second equation is this. Now y would be 1 plus 7r, and we said z itself was r. Right? And r can be any real number. It's anything we want it to be. So there is our solution set for this problem. Okay, last problem for this clinic, right? We have this system. So let's go ahead and set up our augmented matrix. Yeah. The 1, 1 entry is our first pivot. So we zero everything out below it. Now that 2, 2 entry is our next pivot. So zero out everything below that. The 3, 4 entry is our final pivot. That's already 1. Right? So there's nothing to do except to now clear everything above leading 1s. So since that 3, 4 entry is our first leading 1, we clear out everything above it. The 2 entry is our next leading 1. Okay. We look at this and we go, well, column 3 does not have a leading 1, right? So x3 is going to be a free variable. And so is x5. So I'm going to say x3 is r and x5 is t. So our solution is going to be a set of ordered quintuples of this form. 21 minus r minus 24t, negative 7 plus 2r plus 8t, r 3 minus 2t and t, right, such that r and t can be any real numbers. Right? And that will do it for this clinic. So the next clinic will be finding the inverses of matrices by using row reduction, right? So we previously saw how we can do it by setting up a system of equations, right? And then using method of elimination from algebra. Well, now we're gonna see how we can do it simpler by just using row reduction. So I will see you all in the next clinic.